So, Ms. Avantika, accuracy and errors in measurement, you'll have to do one thing for me. See, there is some story about instrumental error, systematic error, personal error, random error, effects of errors. So, this story you'll have to read. This is very important as per your physics practical, because during Viva they will ask you questions like these. This is very important for your class test, for your college test, because they will ask you question like this. Ms. Avantika, am I clear?
Yes, sir.
So this story part you'll have to cover by yourself. I'll be more focused on the numerical part. Yeah. So the first thing that we need to understand is, and basically what I want to tell you is, how will this error analysis be important for you? Let me take an example and try to tell you how this becomes very important for you. Okay. So let us assume that you are in your physics practical and you are doing some experiment like this. In an experiment to measure focal length of a concave mirror, the value of focal length in successive observation turn out to be 17.3, 17.8, 18.3, 18.2, 17.9, 18.9. So you and your group mates are doing an experiment for measuring the focal length in the physics laboratory. So these are the measurements that you have: 1, 2, 3, 4, 6 observations that you have. So your teacher asks you that what is the mean absolute error and what is the percentage error, express the result in a proper way. So another experiment that can be, so for example, you are in your physics laboratory and you are doing a experiment where you are measuring the refractive index. So 1, 2, 3, 4, 5, 6. So your teacher has told you to take at least 6 observations. You have taken the 6 observations, and now finally you have to present the data to your teacher in a format like which looks something like this: 17.9 plus minus 0.25%, or it looks the format looks something like this: 1.51 plus minus 3%. So the whole purpose of this lecture is just to understand that how this error analysis, when we are doing experiment in a laboratory, how is it presented. Another kind of experiment that you might be doing is you are measuring the period of oscillation of a simple pendulum. Now 1, 2, 3, 4, 5, you were able to get 5 observations. Now how do you present the data? How do you present the data to your teacher? Your final data should look something like this: 2.62 plus minus 4%. What does this mean? How do we arrive at this point? That is what we will try to cover in this lecture. And in the second lecture, we will try to understand this combination of errors. This is very important. Usually in competition, this is a very common question which is asked during the competition from whole of the chapter. So Avantika, are you here with me or have you gone to sleep? Okay.
No, I'm here.
Okay. So this is what we want to cover. Now let us look at the definitions that we will require. It's a pretty simple concept, not much of R&D is required. So suppose there are n readings taken for the measurement of a physical quantity A1, A2 till An, then the mean value is given by this. And so this is a simple mean that you take. So for example, you are taking the time period of a pendulum. You have taken those 5 readings. You add them up. You divide by 5. This is what you have done from class, I think, 7th or 8th onward. So any doubt in this part, Ms. Avantika?
No.
And usually students face a bit of difficulty while writing this. What this means is summation of readings, where the readings are going from 1 to n, and whole of this is divided by the number of readings which were taken. Let us try to understand this. So for example, I am trying to measure the time period of a pendulum. So the readings that I have, let us assume we take that example only. So the readings that I have are 2.63 centimeter, 2.56, I'm sorry, second, 2.56 second, 2.42 second, 2.71 second, and 2.80 second. So these are the readings that I have. So what I need to do is I need to just add them up: 2.63 plus 2.56 plus 2.42 plus 2.71 plus 2.80, and I just need to divide this by 5. So this information that I get just by simple addition of and dividing by 5, this is called this mean value. Any doubt here?
No, sir.
This is called the mean value. And let us try to understand that sigma, how that sigma is written. So let us assume my readings are 5, like has happened in this case. How will I write this? I will put a sigma sign. I will write a xi here, where I is going from 1 to 5. Basically, what this means is that I have five observations, and this whole is divided by the number of observation, which is 5. And this can be written as 1 upon 5 sigma xi. I goes from 1 to 5, and the general format of writing this is 1 upon n xn. I goes from 1 to n, and in the textbook that we are referring to, they have written it like n goes from I to n. Any doubt, Ms. Avantika? Actually,
No, sir.
they have used I here. So let me write this as I, because then it will confuse. Both n will confuse. So I will write xi here. I goes from 1 to n, or I can write this as ai. I goes from 1 to n. Now it makes sense. Are we clear?
Yeah.
So the first term is pretty simple. The mean value is, you just take a summation of whatever number of observations you have, and you divide by the number of observations which are there. Okay. The second is magnitude of the difference between the mean value and each individual value is called absolute error. So what this means is, I calculate this. Let us take this example only. I calculate this, and on calculating, the answer that I get is 2.624 seconds. Ms. Avantika, is it making sense?
Yeah, sir.
And because I have done significant digits, I have done in detail rounding off, I understand, because there are 3 significant digits in the data that I have generated. So there can't be more number of significant digits here. So this has to be rounded off to 6.2 seconds. Ms. Avantika, are we clear?
Yeah.
So mean value A bar is given by 2.62 seconds. Ms. Avantika, are we clear?
Yeah.
Okay. Now we want to understand what is called the absolute error. The absolute error, let us first look at the definition first. What they are saying is that absolute error is magnitude of the difference between mean value and each individual value. Mean value and each individual value. So let us look at the data. The mean value that I have is 2.62, and individual values that I have, let me write it here. And the individual values that I have are 2.63, 2.56, 2.42, 2.71, 2.80. Each of these will be subtracted from the mean value, because the mean value is considered to be the true value. Ms. Avantika, are we clear?
Yeah.
I calculate this value. Whatever answer I get, I will take a modulus of that. Ms. Avantika, are we clear?
Yeah.
What is modulus? Modulus is pretty simple. Modulus implies that it will be positive. If the answer is positive, it will remain positive. But if the answer is negative, then I'll have to make it positive. What that means is, so for example, I have 2.63 minus 2.62. So this would be equal to 0.01. So the modulus is 0.01. 2.56 minus 2.62. Now, if you observe this, this would be minus 0.06. This modulus means I'll have to make this positive. 2.42 minus 2.62, this would be minus 2 minus 20. I'll have to make this positive, so this will be 0.20. Mr. Mantika, are we clear? This is the modulus
Yeah.
sign. This is the modulus sign. This is how the modulus is written in mathematics. 2.71 minus 2.62, this will be 0.09. This is positive anyways. So modulus has no work to do here. This is 0.18, so this would be 0.18. So these values which I have written here, these values are the absolute error. So first I calculate the mean, and then I calculate the difference between the individual value and the mean value, and then I take a modulus of that. So that will be the absolute error. Ms. Avantika, any doubt till here?
No.
So in simple words, absolute error is equal to true value minus measured value. This mean that we have taken, this is considered to be the true value. The mean is considered to be the true value, and the measured value. So, for example, when we are taking the individual values, what is the difference between the true value and the measured value? I will write the individual value here. And because it is a modular sign, it doesn't matter. You can write this as measured value minus true value also. Because anyways, the modulus will take care of the sign. Mr. Vantika, are we clear till here?
Yeah.
So what I have done in step number 2 is I have taken these individual differences. So these are the individual differences that I have taken of the observation from the mean value or the true value. वैसे भी कोई doubt है यहाँ तक? Yeah. And then next, what we do is mean absolute error. What is mean absolute error? Or all that it does is that whatever be the errors that I have, I add them up and I take a mean of them. Are we clear, Mr. Vantika?
Yeah.
So all that I need to do is I need to add these up. We'll do a practice question. I need to add these up. So 6 plus 1, 7, 16, 24, 2, 4, 5, 0. Add these up and take an average of these. So how many values are there? 5. So I will write this as 0.0. I'm sorry, 5 1 the 5. 5 1 the 5, 0, 8. Mr. Vantika, are we clear?
Yeah.
Let us trouble Mr. CB. भाई CB, ये आंसर ठीक है? 0.108 क्या होना चाहिए? क्या हुआ? नहीं, आप एक बात समझिए, ये जो 2.63, 2.56, 2.42, 2.71, 2.80, these are the observations that you have taken. Now, of course, there might be some error in it. You don't have to worry about the error. Now we just have to give a mathematical treatment to whatever observations that we have. So what I'm trying to tell you is that maybe 2.63, 56, 71, 80, these are the observations which were taken by you. But this 2.42 were taken by some friend of yours. He might have made a mistake. All I'm trying to tell you is that this is the observation. These are the observations which are given to you, and you have to give the final answer as per this data. क्या हो गया? So, Mr. CB, any doubt? Okay. Now, what I'm trying to ask you is that these are the figures that we have: 0.01, 0.06, 0.20, 0.09, 0.818, and we got a average of these, and we got the average to be 0.108. Now, what I'm trying to ask you is 0.108 the right answer? So, what should we write? Mr. Vantika?
Yes, sir.
What should I write? Rather than 0.108, what should I write?
You're asking me to round it off.
You can give any answer that you want. Whatever you feel right. What, as per the rules that we have done, as per the rounding of rules that we have done, what should be the right answer?
0.
When you are adding the decimals, so what is the rule for adding the decimals? Do you remember the rounding of rules? Can you look at the rules?
I would probably say 0.1 to the nearest.
Can you look at the rules that you have noted for rounding off?
Yeah.
देख ले भाई, जहाँ लिखा था देख ले.
I feel it must be 0.1.
So, Mr. Vantika, what we had decided at that time was that when we are multiplying and dividing, then the significant numbers are dependent upon the lowest significant digit which are being multiplied. But when we are adding or subtracting, then it depends upon the number of decimal places. So because we are adding these numbers 0.01, 0.06, 0.20, 0.09, 0.18, the digits would be dependent upon the number of decimal places which are being added, the places of decimals. So there are 2 places of decimal. So your final answer should have only 2 places of decimal, and 8 would be rounded off to 0.11. This would be
One.
the final answer. Are we clear?
Okay. Yeah.
So this 0.11, this 0.11 is the mean absolute error. Is the mean absolute error. Do you see this?
I took rounding off to 1 decimal place.
But Miss Avantika, that is what I'm trying to tell you. That when we were doing significant digits, when we were doing rounding off, that is why we had, very closely looked at all the rules, regulations. Have you understood my point?
Yeah.
Because when you start doing your practicals in your school, in 11th as well as in class 12, this will be very important for you to understand how the rounding off is done, how the significant digits are taken. When addition, what are the rules for rounding off? When you are adding, when you are multiplying, dividing, what are the rules? You should be very clear about that. Am I clear?
Yeah.
So now I have found the mean absolute error, and mean absolute error as per my example is 0.11. Now let us look at the next step. Now what they are saying is ratio of the mean absolute error to its most probable value is called the relative error. So what they are trying to tell us is that our true value, as per this data, the true value that we have taken is 2.62. So what you do is you take 0.11, this value, and you divide it by the true value that you consider in your data. Ms. Avantika, are we clear?
Yeah.
So this is what will be called as the relative error. Are we clear?
Yeah.
And if you take a percentage of this would be the percentage error. Are we clear?
Yeah.
So if I just multiply this by 100, the figure that I will get would be my percentage error. So let me use my Kelsey. 0.11 divided by 2.62. So 4.2. Two significant digits. So I am adding, subtracting. It will be 2 significant digits. So the answer that I have is multiplied by 100. The answer that I have is 4.198. And using the rules of rounding off, the answer would be 4. Minimum of maximum of 2 significant digits. So I can have only 4.2. So 4.2 would be the, in terms of percentage, this is what the answer would be. Ms. Avantika, are we clear?
Yeah.
So 4.2%. Yeah. 4.2% is the, 4.2% is the percentage error that I have. Yeah. And if I want to present this, if I want to present this data, I will present this data in the form of 2.62 plus minus 4.2%. Ms. Avantika, is it making sense or not?
Yeah.
वैसे भी समझ आया नहीं यार. So let us review the whole process again. So I'll have these, let us assume I have these 5 figures. First thing that I need to do is I need to find the mean of these 5 figures. So whatever mean I have got, whatever mean value that I have got, this will be considered to be the true value. Are we clear?
Yeah.
Then I'll take, let us assume this to be y. Then what I'll do is I will find the absolute value of each of the observations. So x minus y modulus x minus y, or modulus x minus y modulus x minus y modulus, and so on. Let me call this x1, x2, x3, x4, x5, x2, x3. Yeah. So that my confusion is minimized. Are we clear?
Yeah.
So then what I do is I take a mean of these values and let the mean of these values. So x1 minus y modulus plus x2 minus y modulus plus x3 minus y modulus. Yeah. Divided by, I have taken 5 values divided by 5. So whatever my answer be, let the answer be z. Are we clear?
Yeah.
And then what I do is I can have, either I can have an answer like z upon y, or I can take a percentage of z upon y. Is Avantika, are we clear?
Yeah.
So if on one page I want to see what are the things that I am using, so the first mean value that I have calculated, that would be called the true value. This is the true value. then the absolute errors of each of the individual values. So this would be, actually there should be a modulus sign outside. Then what I do is I take the take the mean of whatever I have got in step number 2. So this is the final absolute error, and then I can calculate the fractional error. It is called fractional error as well as the relative error. So the figure that I had got here, this divided by this true value would be the relative error or the fractional error, and then the percentage error in terms of percentage, this will be this figure divided by the mean value multiplied by 100. So basically, the only difference between fractional error and the percentage error is that the percentage error is multiplied by 100. Is something, is it making sense or not? I think the
Yeah.
process is pretty simple. So we got doubt, I and when you have to present the data, the data is presented in terms of the true value plus minus whatever answer that you have got here in terms of percentage. Are we clear? So let us try to do a question so that whatever we have discussed till now makes sense to us. Okay. Can you do question number 3?
Yeah.
Yeah. You can use a calculator, that is not an issue.